Welcome to the first of InGuardians 2019 series of webinars. I'm your host, Mike Boer, and today we kick it off with software-defined radio with even more awesome. It's going to be epic. We are joined by Larry Pesce, our Director of Research, my good friend, fellow bladesmith, and all around just an amazing instructor, great person to share some of his kung fu with us on software-defined radio. So Larry, take it away.
Awesome. Thanks, Mike. And again, welcome to our first of many. So please bear with us if there's any bumps. We're new at this, and we're going to have fun along the way regardless. A couple of things. Yes, we are going to record the webcast, and we will be making it available for those who sign up later. Not a problem. If you have questions as we go along, please do use the question and answer stuff in there. I will attempt to answer as many of them in line as I see them sort of go by. So I will try to make that happen as well. Logistically, I think that's the big stuff. So there's lots of stuff that I want to show you guys today. So let's move into some of the fun stuff, and hopefully all of the demos actually work. I did make my sacrifices to the demo gods this morning. All right, so a little bit about me. I'm a penetration tester, red teamer, whatever the flavor is, and hardware hacker, and the director of research and senior managing consultant here at InGuardians. I'm also a SANS certified instructor. The primary course that I teach and am author of is the wireless course, Security Sec 617. I'm also one of the, quote, silent founders at Paul's Security Weekly. We're a security podcast that's been running 10 plus years at this point. And also host when travel and family permit, which is actually quite often. I also am an extra class ham radio operator, and my call sign is Kilo Bravo 1 Tango November Foxtrot. So lots of fun stuff that I get to do with both at work and as a hobby around radio. And I really enjoy it and want to give some of that passion to you guys so that maybe you'll find some interest in it. And talk about how we can sort of use this within some pen test environments and what this whole advent of software-defined radio really means to us. All right, so to give you a little bit of background, this whole advent of software-defined radio, has just blown up in the last couple of years. We have a lot more readily accessible hardware, which we'll talk about some of it. And lots of folks that have taken an interest into discovering previously unknown signals and doing some analysis on them, and are sharing their projects. As a result of this massive influx of software-defined radio and the readily available of hardware and software, we now are being exposed to areas of the wireless spectrum, RF spectrum, and things that we've just never been exposed to before. And many of these things that we're now discovering, we're now starting to interact with, have some potential security implications. So now moving into those environments, we definitely want to consider some more broader scope of what's in our environment and what risk does that pose to us. So to that, I want to start illustrating some of the things that we can and can't do with software-defined radio, and then steer you in the direction for some things that might be fun to get you down that path of maybe doing some additional exploration. All right, so looking at the software-defined radio platforms, they're many different types. They're not all created equal with various capabilities, send, receive capabilities. Some receive only. Some can receive with a much greater breadth. They can do higher sample rates, so more resolution. You pick the right tool for the right job. But some of my favorites include the Hack RF with receive and transmit, which runs around roughly $300 US. Another one, the Blade RF, their entry models start at $375, and then they have some other models that the price goes up just a little bit. Receive and transmit as well on the Blade RF. Edis, arguably the best folks in the industry for some of the software-defined radio stuff. Their B200 Mini, roughly $800. Receive and transmit, really good capabilities there. And with the Edis stuff, $700, $800 is sort of the low end, and you can easily put together a software-defined radio package, rack mount, you name it, from Edis. That's $100,000 easy. So they really have a wide range of stuff. But arguably one of my just favorite just utility throw in the bag, carry around with you, is the RTL SDR. It's a digital TV tuner that folks found could be turned into a software-defined radio through some custom drivers. And while it's receive only, it's only $35 for a really, really good one, such as the one from rtl-sdr.com. These are the ones that I like. They have a nice metal case. They come with some antennas for $35, which is on the higher end of the cost for these. But for $35, I can get a couple, and I can toss one in a bag, and I can have one with me. And it's not going to get me the great feature set of the Hack RF, the Blade RF, or the Edis B200 Mini, but it's going to get me a really interesting starting point, and just for doing some listening. And that's some of my favorite things to do. So receive only, but we'll add some features to this later. Okay. Now, I love doing receive wherever I'm at, just because when I move, the RF environment changes. Okay. This is weird because I love the autocorrect that happened on this slide. I don't necessarily find singles when I travel, but I do find signals. So that one's kind of an interesting one. Just hope my wife doesn't see this, right? Because but yes, finding stuff that I didn't know that was there whenever I move around, and then when I find something, what is it for? What does it do? How can I interact with it? And what was the purpose of this signal that was there? And in many cases, you start discovering these things, and you get some analysis, you figure out what the signal is, and you find something that's actually kind of interesting with some unexpected results. And maybe one of these will actually show up in one of our demos today to give you an idea what I mean. Okay. So one of the best ways I like to discover these signals is doing a little bit of a manual analysis with some general ideas as to where we want to look. And my favorite way is to turn the RF spectrum into something that I can hear and see. So one of the best ways, free and on many platforms for that I use, both Linux and the Mac, is a product or a software package called GQRX, which gives us the ability to use our RTL SDR and others to tune in some frequencies, have a relatively wide waterfall display of signal over time and real-time signal display. Now I can see when something is changing in the RF environment and note that something is different, or that there is a signal present that I didn't necessarily know was there before. That's kind of cool. Some other ones are that when we use GQRX, it is at the time of at the place of where we are, what signals we can receive where we are on the planet. But there's been lots of really awesome folks that have taken their software-defined radio of some variety and connected it to the internet. Thank you very much. And then allow us to connect those, and many of them multi-user, and use that remote software-defined radio to listen to signals in various frequency ranges, all of them with different stuff. One of them that is my favorite is the University of Twente in the Netherlands. They were arguably one of the first to have theirs connected to the internet and multi-user setup. And we can now listen to RF signals in specific ranges with their equipment in the Netherlands. And I happen to be in New England, in the US. So we're place shifting that software-defined radio, and that's pretty cool. So when we start looking at that, we'll actually do a quick demo of the Web SDR at the University of Twente. And we'll actually tune to the buzzer, which is allegedly Russian number station, although we don't really know what the actual purpose is. I can't hear the RF signals generated with any reliability from my home in New England, but tuning to those frequencies from the Netherlands, I have a different perspective, a place shift, as you are. All right, so let's take a look and see what a couple of these look like. The first one we'll do is we'll do GQRX to give us a visual display. And I'm going to tune this to where I know a frequency is. I'm going to go to 313.850. And we don't see any signal yet because I haven't actually turned it on. All right. And we'll make it go. I will apologize that you guys can't actually hear it, but you can actually see when the waterfall display changes, to my point. What I'm going to do is I'm going to generate a quick signal here, and it will change the display. Ironically enough, this was a device that I didn't know what the frequency was, and I went to the FCC's website, the Federal Communications Commission here in the U.S., to go get that. But the website was non-operational because of various political items that had happened. So I had to find another way to find the frequency, and ironically, I found it on Wikipedia. Just in their general talking about the particular devices and that they use certain frequency ranges. So I just went and looked in those frequency ranges while generating the signal and eventually found one. So I'm going to press a button and have something change here. Yep. So we have a little blip of red centered on 313.850, and we'll do it a couple more times. And if my wife were here, she'd be going nuts right now, because what I'm actually doing is I'm clicking the unlock on my wife's key fob, excuse me, to her car. So we know it was there. We can now observe the signal, and then maybe we want to find other ways to interact with it later. All right, I'm going to stop this. I'm going to get us set back up for another demo in a little bit here, back at 105. Okay. But one of the other ones we can do is we can also do that place shift with the Web SDR at the University of Twente. And I'm going to start the audio just so we can interact with it. And this is their SDR connected to the internet, pictures of it. And we have a very similar type of waterfall display. And let's zoom in a little bit. And I will go to memories, and the memory that I have is the 4,625 kilohertz, which, if you remember from the slide, is in fact UVB 76, or the buzzer, or the Russian number station. And as you can see with this waterfall display from RF signals from the Netherlands, we do see that there is something happening and it does change. So there is a buzz, stop, buzz, stop, and it just does this over and over again. Okay. So again, similar type of things, different feature set, but the ability for us to place shift that. All right, back to some slides here. All right, so what's next? So wouldn't it be neat if we could do that on our own? So the Web SDR stuff, much like the University of Twente is doing, is in fact all closed source, semi-closed source. They will happily share the software with you, but you have to agree to put one of your software-defined radios on the internet. We just can't keep it for us. So some folks decided that it would be nice if we could have an open source alternative, and they created OpenWebRx, which uses the RTL SDR $35 dongle and a Raspberry Pi to do the radio receive. connect it to your network. You can share it over the internet if you choose to or not, and can support up to 4 simultaneous users. Raspberry Pi is a small platform. It has some, in my opinion, issues. It's not as fully featured. You can't change what frequency you're listening to with the display. You actually have to stop it and restart it. The whole web interface and you name it. However, one of our folks at InGuardians, Faith, has gone and pulled down OpenWebRx and started adding some new functionality so that we can start changing that in real time with the OpenWebRx display itself. And I will show you that with Faith's modifications. And I'm going to say it is very much alpha. And it is very much a work in progress, but more progress is being made every day, and it's a little bit touchy still. So keep that in mind. But for free, that's in my opinion quite amazing. Okay. We can, quote, fix some of those issues with OpenWebRx, and even over some of Faith's modification. There's a re-implementation of WebRx with the Kiwi SDR. And the only way you can get the Kiwi SDR software is through some software licensing, I guess, as it were, and through the acquisition of a custom software-defined radio from Kiwi SDR. And they have a kit that includes a BeagleBone Green and all of the firmware and their version of OpenWebRx to do a lot more things, a lot more semi-closed source web SDR with all of the little bookmarks and signals identification and more analysis of those signals. But it's $300 for receive-only software-defined radio and a BeagleBone. Yeah, that now starts to get into the territory I have to ask my CFO if that's something I can acquire. All right, so let's take a look at both of those. All right, so OpenWebRx, it's been running in the background here with Faith's modifications. And we have a similar type of waterfall display. It tells us what frequency we're tuned to. And that's pretty cool. We can actually change here in the display as well and have the audio come out of the various signals that we're looking at. Similar types of things to GQRX. Now, while this one happens to be sitting on my desk here in my office, I could very easily ship this to a friend and allow port forwarding through their firewall to gain access to something like this as well. Okay, but the thing that I think that is that's great that Faith has done for us is that we can actually update the frequency now here in the display to 105 megahertz. And if we wait a second, it will add the waterfall display will actually change because we've actually instructed the RTL SDR to tune elsewhere. Now, it takes a little bit of time just because of the way the FIFOs are set up to make this happen. And we now see that something has, in fact, changed. The display is different now that it's actually gone and done the change. So I think it's pretty cool. It's getting there. You'll note that it says 105 megahertz here. The rest of the display hasn't quite updated yet. And that's some of the things that Faith is still working to make happen. All right, so what else? The next one is Kiwi SDR, and in fact, OpenWebRx with their modifications, significantly different in what they've got available. And it figures, it crashed on me, so let's reload it. Maybe. Come on. Huh. It worked before. It's always the way, right? All right, there we go. There we go. That's better. Yep, you can go away. So we got our waterfall display. I said go away. And we can change various frequencies and so forth. Let's see if we can see some different signals here. Looking for WWVH or WWV for some time synchronization sources. I want to say I had good luck at time 5 at the 5 megahertz. And so there's some stuff here. This one is a little bit more robust in that we can actually scroll and change the frequencies this way, and a lot more options. You get what you pay for at $300. Um, pop. Unlike it says, it is in fact not in Taronga, New Zealand. It is literally out of the box and have had very little time to actually change any of the default settings. But I came in and started listening to stuff, and it was great. So let's take a look at the 11 meter broadcast range. Not so much. I have a really poor quality antenna on here, and not the Mike Poor variety, because that would be an awesome antenna. I have an incapable antenna attached to this one. Okay, so more fun stuff there. All right, so some other fun things that we can do. Using our RTL SDR, we can use the RTL SDR with some utility type packages to tune into various frequency ranges and capture signals and automatically do some decoding. One of my favorites is a utility called RTL 433. It tunes your software-defined radio, your RTL SDR, into the 433 megahertz ISM band, the industrial, scientific, and medical band that doesn't require a license for anyone to transmit. This is all of the devices in your businesses and homes that have remotes and so forth and so on, so that they can be distributed to the world, and you don't have to go through this crazy licensing requirement to make it happen. Okay. There's all sorts of stuff here because it's open. Okay. RTL 433 knows how to decode a bunch of these because folks have captured signals, they've done some analysis and figured out what they were and what all of the breakdown of the signals actually are. And then have contributed them back to the project for a fingerprint of these, which then can be used to decode it. It can also be used to do a generic capture, which we can then take that output, write it to disk, and do our own additional analysis, and then replay them at a later date, and or replay them through the software so that we can do additional analysis as well. And in this case, you start finding some very interesting stuff. Okay, so I'm going to take a look here, and not that one. We'll bring up. Is it this one? Nope, it's this one. It's not that one. It's this one. All right. So looking at this here, we'll run RTL 433. This is native right to my Mac here. And it is not going to find a device because it's captured by GQRX. Let's try that again. Okay. It found my RTL SDR. It's tuned to 433.92 megahertz in the middle. And I got lucky because these are typically intermittent. Excuse me. It did find a device that had just transmitted, and RTL 433 knew how to decode that data. And it turns out it is my Oregon Scientific PCR 800, one of my weather sensors. And this one happens to be for the rain gauge. And we've had 11.3 inches of rain. I think I was out there playing with it to try to make it happen, to add some data to that. So there's about 100 devices that are available with RTL 433. Some of them are better than others for the decode, and some of them more reliable. But it's still pretty neat to find that there are things there that we hadn't been able to see before. One of the ones that came up when I was playing with this at home was that I found that there was a device that was called DSC Contact. And after figuring out what that was and seeing the signal, it turns out it is the open-close sensors for my next-door neighbor's alarm system. And now that starts making me ask other questions. If I could capture the window stating that it's closed, could I just spam the alarm system saying that the window was always closed even though it wasn't? Or on the converse, could I capture it when it's open, replay it at a later date at 3 days later at 2 o'clock in the morning when the alarm is armed at the middle of the night and set off my neighbor's burglar alarm in our house? So now this starts making me ask all sorts of other fun questions. All right, so we did the demo of RTL 433. Because the transmissions that I have available to me are intermittent, I didn't know if we were going to find one. We found one. That's great. Okay. Another one of my favorites is a utility called multimon-ng. And while not specifically for radio, it can take data sent to multimon-ng as audio and then can convert it into a couple of different protocols that it knows how to decode the audio for. It will do DTMF, multi-frequency tones for dialing a phone. It will decode Morse code. My favorite, however, is looking at POXAG and Flex pager traffic because it will decode those as well. It just needs audio, and we can give it raw audio as an input via a pipe from a remote RTL SDR or through the RTL FM package. And in my area, there may be some interesting stuff at 929.01 megahertz, or roughly in that range. So by using the RTL SDR to tune to that frequency with RTL FM from the command line, we can pipe it to multimon-ng to have it decode various protocols. Morse code is also a lot of fun, which is still in use quite a bit by ham radio operators. Okay. Now, Larry, you're saying, great, that was lots of fun. This is all receive only. Yeah, and when I go into this is what I want to do first, is listen. So I can get a taste for what the environment is like, set that baseline. But there may be occasions where I want to actually do some transmit. Cool. We can transmit on the cheap. We don't necessarily need to upgrade right away to one of those more expensive software-defined radios, say the HackRF, $300 or so. We can do this a little bit more inexpensive, and it's not perfect, but it's kind of fun to get started with. One way we can use PiFM, which uses a Raspberry Pi, and the software toggles one of the general purpose input-output pins, the GPIO pins, to generate RF energy. So by toggling a pin on and off really fast, it creates RF energy. Neat. And in this case with PiFM, it generated an FM broadcast. Very similar to something like you'd see in your cars that didn't have a tape player adapter and you wanted to listen to your phone audio in the car, and you have the little FM transmitter that plugs into your cigarette lighter or the power adapter, that type of thing as well. Another variant is RPi-TX. And RPi-TX does the same thing as PiFM with the toggling of the GPIO pin, but they've implemented a lot more than just frequency modulated audio. There's a whole bunch of other fun stuff there as well. We can also use some FL2K stuff. We'll touch on FL2K momentarily here. And the latest, quote, update to RPi-TX, RPi-TX2, has become even more amazing, in my opinion, because RPi-TX2 gives us the ability to use the RTL SDR and transmit at the same time, effectively, so that we can either we can shift frequencies and rebroadcast them, or we can do capture and replay. All right, so RPi-TX does that GPIO transmit. We plug a little wire into the header on the Raspberry Pi to increase our range, and we now have the ability to use the RTL SDR to do capture and replay, and even better, with a menu. So I don't even need to remember all these complex command line type of stuff. I can do it right from a curses-based display in like an SSH session to the Raspberry Pi. Now, toggling the GPIO is not perfect. It's kind of a bodge. It's it's a hack, it's a kludge, whichever you want to call it. It's not clean, it's not efficient, and it spreads out a lot further than you actually expect, with some harmonics and all sorts of other fun stuff. Using it, you're not the best steward of radiomanship by using it for long periods of time, but it definitely proves that it does work and can do some very interesting things. All right, so let's do a quick demo of RPi TX2, and that one is this one. Okay, we're going to use the RTL menu. All right, and we're going to choose a frequency here. In this case, I'm going to do 345.0. So input frequency, where am I going to listen to? Because I have an RTL SDR attached to it. Okay, I'm going to leave the gain where it is, and I'm going to choose the output frequency of 345.0 because I want to transmit whatever I capture back out on the same frequency. Okay, so in this case, I'm going to start recording, and then I'm going to make a signal happen, and you guys will hear the result of said signal, and then I will play it back later. Okay, so what I have here is a very inexpensive doorbell with a button, and I'm going to press record, ring the doorbell, and then stop. Record. Oh, someone's at the door. Okay, and now we'll stop. I'll put the remote down. We'll go down to play and replay it and see what happens. Yep, there it goes. So in less than $60 in hardware, Raspberry Pi, and the RTL SDR, and an inexpensive piece of wire, we're able to do capture and replay based attacks. Now, Larry, you said, that's great. It's a doorbell. It may just be a little bit annoying. But if you remember earlier with with GQRX, we captured at 313.850 megahertz, which happened to be my wife's key fob for her car, which in fact does not use rolling codes and is subject to replay-based attacks. Now, why do you care? Well, when was the last time you left your laptop in the car? Well, you probably didn't leave it in the car. You left it in the trunk so that nobody would see it, and or it was behind an additional set of locks. Now, if we could actually replay unlock codes, we could potentially break into that car and steal a laptop out of the trunk. Thinking about those types of scenarios. Okay, moving along, because there's still lots for us to talk about. There's another way we can do some transmits, and also inexpensively. And this one I thought was just absolutely fascinating. Excuse me. Is a software package called FL2K. And it is a set of custom drivers for the FL2000 chipset in order to, very much like the Raspberry Pi based transmitter, toggle a GPIO pin for transmit on the FL2000 chipset. And these chips are often found in very inexpensive USB 3 to USB 3.0 to VGA adapters. Yeah, this is a video adapter, USB 3 to VGA video adapter that we can get for $15 roughly from Amazon, typically Prime, so quickly, and we can use this to transmit radio signals. That's kind of interesting in that there are now potential for just random devices in our environment that we could use to transmit radio signals with some custom software. That becomes very interesting in my mind. All right, let's see if we can make this demo work. This one gets a little touchy because it does require USB 3. Oops. It does require USB 3, and I do have a machine here with USB 3 attached to it, and this is not the one I want. This is the one. It's a Chromebook, so it's not the speediest. And what we'll do is we'll also start GQRX at 105 megahertz, and we'll get that rolling here. And we see that there's a signal over here at 105, almost 106, which 105.1, which happens to be a radio station. But we're going to go back right over here to 105 roughly, and let's see what happens. So in this terminal, I have a shell script because I can never remember the commands to use the FL2K software to transmit FM of this sample wave file on 105 megahertz, and I had to do some math for the sample rate and so forth to make that happen. So there we go. Let's start it and see what happens. Okay, so I'm going to start it, and I'm going to switch back over to GQRX, and we see that something else has now been added to the spectrum right in there. And if we go back here and we stop it with Control-C, we'll note that it has now gone away. It's a little bit difficult to see, but we can see that there's been this new addition of a signal here. You'll note that it is significantly overpowered by the actual station at 105.1 in comparison. But let's see if I can actually make this even better. Let me give this one more try here. Transmit again, go back, see if we can make it a little stronger. There we go. I just repositioned the antenna. So now we have a significantly stronger signal. And this is actually using a VGA, that VGA adapter as well. And I think it just crashed. Yep, it's not particularly robust, especially running on my Chromebook because it chews up a lot of CPU, and the Chromebook really just can't handle it. And quite honestly, it's a hack, and it's not really even meant to do this. So, but still, we have a very inexpensive device that we might find in our environment that can be used to transmit audio. And audio can be effectively data, as we saw with multimon-ng. So thinking about that, we can use FL2K to send FM modulated signals. Great, we can do radio. And in fact, that sample is one of my favorites. It's Rick Astley, and you guys can probably guess which one it is. So lots of fun there. But with FL2K file, we can do so much more. It just takes whatever's in a file for data, and then we'll transmit it into the air on whichever frequency we choose. If we can create files that have contents of all sorts of fun stuff, we can transmit that. For example, digital TV broadcast, digital audio broadcast. If we could record and create the signals for GPS, FL2K file would do that. GPS, UMTS, LTE, GSM, you name it. And in fact, the screenshot here over on the right is an FL2K, an FL2000 dongle transmitting, if I remember correctly, GSM to create a cellular base station with that. Now, this becomes lots of fun if we have a really inexpensive device that we can create all sorts of stuff with. But you'll note that it is very close to the devices itself, and the transmit range is not all that great. But they're not particularly robust, specifically FL2K. However, we can start to make them better. FL2K has tons of features. ARPI-TX2 is lots of fun as well. Antenna selection is questionable. On my FL2K, I didn't have an antenna attached to it. It was just the adapter. It was just the VGA adapter itself. Ted Yapo, I believe that's how you pronounce his name. That's how I'm going to pronounce it, has created some adapters to plug into the FL2K VGA to USB adapters, plugs in just like it would be a regular VGA stuff, that creates some filtering so we can be better radio stewards, and the ability for us to add our own antenna of appropriate length for where we want to do our transmission using industry standard connecting types. This becomes interesting in that, it's a do-it-yourself type of project, but for just a handful of dollars, we can now put in some better radio stewardships and some better antennas on something like one of the FL2000 chipsets. We can then potentially even tie this to some sort of amplification so that we could increase our distance. Now, we have to be careful legally and just be good radio stewards, but this is still very inexpensive stuff for us to make happen. Okay. So in my opinion, why is this important? Well, we now start asking ourselves what's next. Okay, I think as the future goes on, maybe a little conjecture here, we're going to start to find more devices in our environments that can be repurposed to do transmit, like a VGA adapter. We now necessarily don't need to have nation state capability or some really determined attacker to be able to do, quote, out of band data exfiltration. For example, Faith and I worked on a project together called Vapor Trail, in which we used a Raspberry Pi, where Faith designed her own digital broadcast mode for us to exfiltrate small quantities of data, text specifically, with our Pi TX. What if we could do this with other devices, say FL2K, inexpensively? Now this creates a whole new avenue inexpensively for us to do transmit and receive of radio that maybe folks aren't looking for, don't have any idea that they're there, I have no concept of anything that they need to be looking out for. And thinking of that, if you look at some of Dragos's work that he's been talking about a little bit, he's actually looking at all sorts of various devices to see what transmissions are coming out of them, and he's finding some very interesting, in my opinion, stuff. Whether or not it's anything of any value, more analysis yet to happen from Dragos to see if it's something that it's doing potential data exfiltration. Has it been happening all along and we didn't even know it? Okay, so really, what's next for this? What does this really mean for data exfiltration out of organizations when the internet detection outbound is really good? And then potentially, how do we even do command and control within reasonable distances of the facilities, using all sorts of new various methods for RF-based transmission that's not Wi-Fi, Bluetooth, Zigbee, you name it, something that's been unknown in areas that folks aren't looking. So thinking about that, we now need to potentially up our game to start doing some RF detection for unknown signals and setting those baselines so that we can now find what could potentially be the next evolution of data exfiltration and command and control infrastructure for botnets and or you name it, or any sort of attacker's activity. Okay. We then start to even potentially get more complex with some of these type of stuff. Okay. We did some transmit with FM radio with FL2K. It wasn't great. As you saw, I had to do it twice, and I had to move my antennas around, and you name it. It works. It's not the best, but we could certainly do better. That would be interesting with just FL2K itself if we had some better radios and some of those same features, such as GPS. We just need to use better tools, such as the HackerF. And now we can start seeing that things are getting to be more complicated. Okay. Talk a little bit about GPS for a second here. It's been around for quite some time for us to determine where we are on the planet. Based on the location where we are is derived from time and the satellite position and a bunch of math, and knowing where those satellites are so that we can determine our position. Okay. So why would we want to spoof GPS? Well, in this case, clearly so that we can create our own paths and play Pokemon Go so that we got to catch them all, right? So, yeah. No, that's a joke. I mean, we could use it for spoofing GPS for Pokemon so that we don't get caught cheating by network-based stuff because they build all that stuff in now. So let's actually just hack the infrastructure, GPS. Okay, so in this case, they're using the joystick to actually change the location. It's affecting the output of the Pokemon Go by actually thinking that they're walking. some other things, but that's great with Pokemon. But what else can we do? Well, we could do very important person attacks on automobiles to potentially direct them where they necessarily shouldn't be, make them drive off a cliff by accident because people just follow their GPS blindly. We could attack very important cargo on various shipping vessels because there's never anything that's sent by ship. Or we could use, quote, anti-drone techniques to cause drones to do bad things. And in fact, there was at least one example where GPS was allegedly spoofed to cause one of the US military's drones to think it was actually higher than it was and crashed it into the ground fairly safely and was recovered by others. So, or we could just make them think they're not here and they go away. Okay, so we could do it with FL2K, but not at range and with lots of issues with stability. But if we use something better, such as the Hacker F, the Blader F, and a few others, for one that is meant to do transmit and well, we could have this actually be better. Okay. We can use our Hacker F with GPS SDR SIM. It absolutely works great. We can give it a static position. We can give it a path and or trajectory so that we can have folks move. We can specify the static position right at the command line. The path and the trajectory needs some more data. Either a CSV, ECEF, or a NMEA GGA stream. We can get those by using our own simulator from, for example, the NEMA to UM LabSat from labsat.co.uk for free. So we can generate that to disk and then replay it with our HackerF. It's relatively simple install with a couple of apt-gets and a git clone. The hardest part of all of this is knowing where the satellites are to generate the math to tell the device, hey, we're actually here. And to that, we need some data, the BRDC, to calculate the satellite location. The BRDC describes where the satellites are in the sky so that we can generate all of that math. Okay, so why do we care about GPS spoofing? Well, we can change the location. We can do those VIPs. We can do the VIC cargo stuff. We can do anti-drone techniques. But there's also some other things that we can think about. Is anybody using anything that could allow authentication based on location? Will you only allow me to use my two-factor while I'm in the actual office itself? Well, maybe if we could tell that device that it's in the office when it really isn't, that could be interesting. Those types of things. Okay. In my testing, the devices that I tested again also appeared to have some lasting effect when I spoofed GPS. In fact, would tell the map where I was, and it would shift my location to based on the spoofed GPS location, and would cache it. And would cache that location for 2 or more hours if I didn't do anything, such as reboot the device. It could also potentially affect time because when I was doing the calculation, it was a static and it was a time in the past. So it took that time in the past and changed the time on the device based on GPS with a few other things, and that time didn't reset without some sort of intervention as well. So there are potentially issues with changing that location or even the time, location-based auth, you name it. What about time-based authentication? So anything that uses a PIN that is generated and changes over time. So this could now start to potentially get interesting. Okay. So in these, we're really just starting to show you guys the amazingness that can be had with software-defined radio. There's so many more protocols and frequency ranges to explore. We talked just about a couple in the ISM band, 433 megahertz. We showed some in the 313 megahertz range. So now the question becomes, which one of these are in our environment? That's step one. How do we find them? Then do some analysis on them and find out which ones have data that we can recover, maybe something like POXAG or flex data traffic. Okay. Then from those, which ones can pose a security risk? Which ones have plain text data? Which ones are subject to capture and replay, like the doorbell example? This now becomes a whole new world for us to consider. Replaying the doorbell is great. Recovering plain text is also pretty nifty, but now we have to determine whether those are going to be a risk to us as well. Larry, those examples are kind of contrived for something like that, but yes, these are examples that are really easy for you guys to try out as well, something like the doorbell. But think about what some of the other security implications could be. And what RF devices are in use. For example, I believe there are a bunch of alarm system manufacturers out there that use wireless sensors and wireless keypads. And there was analysis of one that was in the news, SimpliSafe, and that they found that they could capture and replay basically unlock and disarm arm and disarm events from the remote keypad. After additional analysis, they were actually able to recover the pins from remote keypads used to disarm the system, so that they could actually recover the pins. SimpliSafe is a huge company, and in fact is targeted to the home and small business type of environment. Now, probably some ones better in some larger enterprise environments, but maybe there are also similar types of attacks against them as well. So the big one is that this whole explosion of software-defined radio has opened up so much of the RF spectrum for analysis, because we just didn't have the tools to do any of this analysis before. And on this, we now haven't even touched on analyzing anything unknown. And as my good friend Don Weber would say, turning the RF into bits and bytes, turning that signal back into ones and zeros, and then that ones and zeros into something meaningful, for something that no one has ever analyzed before. And now the rabbit hole starts to get going deeper. Okay, so wrapping up a little bit, and if anybody does have any questions, feel free to throw any of those in, and I can devote some time here as well. One, I really hope I pique some interest into software-defined radio, even if it's just at the receive only, and just go and listen and see what you can hear, because there's quite honestly some fascinating stuff out there. Okay, we learned through today that we can do some analysis listening with very inexpensive tools. We also demonstrated some simple attacks with very inexpensive tools. So this is not something that is not doable. I mean, just about anyone can do this with a little bit of time and understand it. Okay, and not spending a lot of money with something like a Raspberry Pi and an RTL SDR. Okay, a lot of the work that we're going to be looking at, even starting down some of this path, has already been done for us. And thinking about those, and maybe with just a little modification, will get us to where we need to do. And in this case, thinking about the capture and replay attack that worked on the doorbell, that may also work on my wife's key fob for her car, they didn't require a lot of technical expertise. That was me literally typing in a couple of numbers and hitting enter, and it went. Okay, we can spend more money to have more capability, and then this now starts, really opening up more avenues, and can really consume us as to what we're looking for. I have just about every software-defined radio that is reasonably priced, and they all do different things well. And unfortunately, now I have lots of software-defined radios, or fortunately, as the case may be. So this is just the tip of the iceberg. All right. So it wouldn't be a webcast without a quick little fun addition for you as well. I did want to mention if you liked our webcast, we're going to be doing a lot more of them. We also have a quote weekly executive briefing via email that is opt-in, and we don't send you all sorts of crazy spammy things. Just we want to help you. It tells you about some of the things that we may be doing in the future, such as our events and trainings. However, it's the one thing at the beginning of the week that we feel that the security executives or the executives in your environment need to consider moving into the week, so that your executives can say, "Hey, did you guys hear about that thing?" And it's not just tuned to the executives. It's just that one thing that I think we should all be thinking about from a security perspective for the week, and largely based out of something that has just happened. And we want to offer advice that you can put into practice right away. So sign up. Great stuff. I do some of the authorship as well, and just about everybody on the team here at InGuardians does as well. Okay. So with that, a couple minutes early, but great. Get you back to your busy work days and much appreciated. I hope you had fun today. I know I did. I'm so excited that all of my demos worked, at least finally. So I'm really happy that all of those worked because I've been stressing about that. But if you do have any questions, please don't hesitate to reach out. Larry at InGuardians.com. You can also get me on Twitter at Hacksforthematrix. But other than that, I don't see any questions coming into the question box. That's okay. If you want to ask me offline via email and such, please do feel to do so. So with that, thank you very much, and hope to see you for the next one.
Thank you so much, Larry, for that excellent presentation, and for everybody else listening, much appreciated. Stay tuned. Also, check out InGuardians.com/webinars for each month's webinars. We've got an awesome one coming up in February with Adam Crompton talking about the ways that we can manipulate and use copy and paste infrastructure for command and control and all sorts of other fun stuff. So like Larry said, thank you so much. And feel free to submit any questions or otherwise and feedback. And we'll see you on the next one in February.